If a balloon has a volume of 5 liters at 20 degrees Celsius, then what is its volume at 90 degrees Celsius? First, let's create a table to separate what we know from what we don't know. We know the first volume of the balloon, V1. We also know the first temperature and the second temperature, but we don't know the second volume, V2. We can also fill in these values with 5, 20, and 90, and we don't know for V2. We can also fill in the units, which is liters and Celsius, respectively. Now that we know all this, we can solve for V2. To do this, we'll use the ideal gas law, PV equals nRT. First off, we know that P, N, and R are all constants, and what we'd like is some relationship of V and T that equals a constant. This way, if we know the change in T, then we can figure out what the change in V is. We can do this with our good friend algebra. By dividing by T on both sides, we get PV over T equals NR, and then dividing by P on both sides, we get VT equals NR over P. This is the relationship we were looking for. That is, V over T will always equal some constant when N and P are constant. Since V over T always equals a constant, then V1 over T1 must equal V2 over T2, since they both equal the same constant. Now we can just plug in the values from our knows and unknowns table. We know that V1 is 5 liters, and we know that T1 is 22 Celsius? No. We have to change it to Kelvin. We do this by just adding 273. Now we can do the same thing on the other side, question mark liters, and 90 plus 273, Kelvin. If we multiply by T2 on both sides, canceling on the right, now we have this really ugly equation, T2 times V1 over T1. Now we can just cancel the k's out, because they're dividing each other, and just plug this into a calculator to get 6.19453. And that's our answer. Also, remember to use liters.